time with me today. I'm going to make this fun. So here's the deal. If you ask a good question, if you ask any question at all, you'll get a little bear. So that's where we're going to start. So real quick, show of hands, how many seniors? Wow, a lot. Great, juniors? Okay, sophomores? No freshmen? All right, good. So what's interesting is I've got 4 sons, just like you guys, which is kind of cool. So one of them actually is another university. He's actually a senior now in mechanical engineering, and he's trying to find a job. So part of this presentation is going to be about a little bit about what we do as far as jobs. So just kind of be aware of that, and again, ask any question. Questions are great, kind of keeps the dialogue going. Otherwise, you guys will be bored if I just sit there and talk for 45 minutes. So let's see what we can do to try and move that along. Any questions for the first bear before we get started? Anybody?
Can I get a bear?
That's a great question. Ready, catch?
Yeah.
It's soft. So you're probably wondering, what's up with the bears? We're going to talk about that in a second. But BNSF Railway, sure, click there it is. Make this easy. So, oh good, fantastic. So I'm going to talk about a bunch of different things, and I'm going to focus first on our agenda. So really talk a little bit about BNSF Railway, talk a little bit about career opportunities and exactly what that means for you guys in the room, and then talk about environmental, and last but not least, have questions and answers. But again, we prefer to have questions and answers throughout. So real quick, how many folks are looking for jobs? Great. Okay, how many, I'm just curious, my son has not found a job yet. He's a mechanical engineer, as I stated. How many people actually have jobs already? Good for you. That is really good. But the folks of you who do not, as I tell my son, it's okay. You know, time will turn and you will get something coming up. Just be aware of it. We want to talk a little bit about what we do. So, BNSF Railway, as the professor had mentioned a second ago, got about 35,000 employees. And to be honest with you, I started with them about 11, 12 years ago. I had no idea it was that large. We are pretty much everywhere. West of Mississippi is pretty much where we are. And what do? We pull stuff. We own locomotives. People have stuff, Amazon, all your packages for Christmas, all that kind of stuff, and we pull it from one place to another. Whether it's coming in from overseas, whether it's Mexico, Canada, whatever. We also do a bunch of other things, which I'll talk about in a second. We deal like we move different materials, you know, sand, and coal, not as much anymore. But a lot of different opportunities for material movement, as well as, you name it, we'll pull it for the most part. We'll pull wind blades and wind turbines, like the ones you have here. And that's pretty cool. Picture one of those huge, monstrous wind blades on top of the road. Lots of questions on how we do that, logistics behind that. So we have about 7,500 locomotives. Sounds like a lot. It's not really. You can think about all this stuff that's pulled every single day. So we're out there, kind of like trucking, but just we can carry a lot more stuff. Trucking can, you know, you've seen a truck before, you said what you can carry. We can carry hundreds of thousands of tons of material. The heavier, the better. No matter how heavy it is, we can pull. It's kind of interesting. So I'm going to kind of go into a couple different things we're talking about here. There's our network. I'm going to spend a lot of time on this, but for the most part, 32,500 route miles. Pretty much west of Mississippi. 13,000 bridges, 89 tunnels, there are about 40 ports, international facilities. It's kind of what we do. And as I go through this, when I'm just be honest with you, I never thought I'd be working for the railroad. Like, railroad? I don't know anything about the railroad. They just stop me and keep me at a crossing. I can't cross in front of them. Well, we'll tell you more about the why behind what we do. So a couple things, talking about what we do ship. I'm not going to go too much into this, but we ship grain, Canada or other. We have to get it from the farmer's land to the ports. Think about this. Grain is one of those things that if it ends up sitting around for a long time, what happens to it? It goes bad. Exactly. Who said that? Somebody said, you said it again, you can't do bears. You want to give a bear to your friend?
Sure.
Okay. Whoops. Good catch. So, grain can be issued. You think about a lot of things like that. If we don't get there pretty quickly, it's going to rot, it's going to go bad. Farmers will be very upset. So we'll talk about that in a second. We also keep the energy process going. Think about all of the different materials that things are burned, like for example in power plants, et cetera, whether it's coal, whether it's other things. We have to move that around, because otherwise we don't have any power, which is kind of a problem. We talk about linking to the world, should we lay asphalt, things like that. We have all these different things we move around. But the bottom line is 44.5 million intermodal shipments. So all those Amazon, whoever buys from Amazon, how many people buy? Oh, cool, everybody. Who doesn't buy from Amazon? Wow, I actually met a guy who did. Just a long story, we won't go there. But anyway, bottom line is all this stuff gets back and forth, gets in those big metal containerized material buildings or material, what I call it, mailboxes, and they get delivered to a local location where it gets sent to your house. So that's kind of what we do for there. Let's keep on going though. But our vision here, I'm not going to read this to you, but for the most part, we provide transportation services that meet our customers' expectations. Now, actually, the first time I saw this, I said, we only want to meet their expectations. I mean, if you were, gentlemen right here, if you were to be told by a professor and say, hey, I just want you to meet the goal of the class, I don't care if you do really well. Usually it's like you want to exceed expectations. Thank you, good job. You want to exceed expectations. I asked that question. Why doesn't it say we provide transportation services that consistently exceed our customers' expectations? Here's why. If we get there too early and they're not ready for it, it can also go bad. Think about that. Trade comes in. If the trucks aren't there to bring it other locations, it goes bad. Congestion, it shouldn't be there if it's there early. It's like, for example, if the gentleman right there, if you end up showing up at this class early, it's 7 o'clock this morning, would that be great? Not so much. I mean, maybe it depends. Maybe you want to get here that early, you can study, but for the most part, you want to get here when you're expected to get here. On-time shipments is what we're talking about. So just want to point that out, if you wonder the why, we just want to consistently meet expectations, that's why. And we end up exceeding as well. So predecessors, how old, it even says it here. Okay, it's an easy one. Whoever can answer this one by looking at the slide, how old are we roughly? 106. Wow, I don't know if Bear's in front of everybody. Who said that first? Did she? The guy got a point right here. He. Can you catch this from there?
Nope, but we'll try.
Yes, you can. Okay. Exceeded expectations. Great. So bottom line is we're 170 years old. That's pretty old. I didn't know that when I first started working there. I was like, wow, that's what? 170 years old. So all these different predecessor railroads got together and they combined and made this BNSF. You can see a few of them. There's the Santa Fe, different railroads that actually became us years ago. And we are now BNSF. So other question for you guys, I'm gonna ask you questions. Whoever answers this gets there. Except for you. Because you got too many. Now, if you get it right. What other railroads do you know? You gotta name 2 other railroads. Gentlemen.
Union Pacific, Burlington, Northern.
Yes.
Union Pacific.
One more. CSX, Norfolk Southern. I heard that. Yeah, you're blessed now. So bottom line is, we are one of many different railroads that actually run stuff back and forth. Again, we may take stuff from the East Coast, it meets us in Mississippi, and we take it out to the West Coast. Just how it works. So we're really one big interconnected facility, if you want to call it, or one big interconnected logistics system. And you think about that, railroads come in, swap stuff around, we pick it up with our engines, we take it on. That's kind of crazy to think about. The logistics associated with picking up some of the stuff and pulling it somewhere else and not losing it, getting it lost as far as the wrong location. It's pretty amazing. So we're going to talk about locomotives in a second, but I just want to keep on going through this real quick. Before I do, so show of hands, who are logistics and supply majors? All right. How many finance majors? Good, good. How many general science or engineering majors? Okay, good. What kind? Which one?
Mechanical.
Okay, good. I know it wasn't a question. Good question. So, as we go through this though, you're all thinking, okay, some of us have jobs, that's awesome. But how do I get a job? For example, at BNSF. What happens when you walk in the door at BNSF as far as a job? So I'm gonna kind of go through this. What's cool about BNSF is we're so big, and we have so many different things that we do, that any one of you in this room, doesn't matter what major you are, if you're poli-sci, if you're language, it could be any one of those things, human resources, of course finance, engineering clearly, we have opportunities for everybody in this area. So I think a lot of folks here are probably thinking to yourself, well, what does that mean? So what does day 1 look like? What does day 10, day 100, day 1,000 look like? That's a real good question. It's that unknown. Who, for the folks who have jobs, few of you, raise your hand again, I can know where you are. Okay, let me talk to you. Do you know what you're gonna be doing? Do you have an idea, like when you walk in the first day?
Yes, I did.
Good. Do you know what you're gonna be doing in 10 days?
10 days, yes.
100
What am I
days?
gonna be doing next year? No.
367 days?
167 days?
367, the next second year.
Graduating.
Right? Okay, good. So this guy's got a great view of his job, which is really cool. A lot of us, myself included, years and years ago, I had no idea. I walked in the door thinking, what am I gonna do? Okay, and they put you to work. So I'm gonna show you real quick kind of the stuff that happens at BNSF as far as careers, which is kind of interesting. So the thing is, if you get in the door and you don't like what you're doing, you change. Or if you do like what you do and you're staying, and you kind of progress up through processes. So I'm gonna kind of get that just real quick, only because there's some mostly juniors and seniors in here. So this, as I stated earlier, kind of shows a quick summary of some of the things we look at. Anybody here like criminal, okay, what's a criminal investigation, what do they call it? You know what I'm talking about, police thing, that type of thing, I forget what it's called. Resource protection, what we call it, for BNSF. Sales and marketing, human resources, legal. If anybody wants to go into legal or compliance, that's kind of what I do as far as the environmental side. Operations, that's the biggest one. Mechanical, engineering, and transportation. So mechanical works with locomotives, transportation works with our hubs where we send stuff back and forth, and of course engineering deals with like building stuff. So you think about that, you're like, well, that's not really what I want to do. Well, environmental sustainability, great place to be into, something I started a long time ago, changed paths many years ago, and look where I am. You can't knock it. Public and government affairs. Anybody in poli-sci or public affairs? No? Okay. And then of course, logistics in general. Anything with respect to logistics, VIT or TS, information technology folks. Okay, we'll skip over this slide, but kind of show you some ideas. So if you come in and you're a mechanical person, so you're a mechanical engineer or science of some type, you'll come in a different way. You'll come in, for example, as a, what they call it, intern at times in the summer, bottom, and you'll progress up to a management trainee, which is really cool. Management trainee is a role where you walk in, you don't really know what you're doing, but they put you in everything. You just think, well, that sounds stressful. No, it's really not. You get to meet people, you get to go into all these different areas, and then when you're done, you say, you know what, I really like, working with the foremen who are out there in a shop, working on locomotives, knowing how they run. Boom, you become a mechanical foreman next. And then potentially more than that, you go into quick operations. You do a lot of different things. But this is what happens in 7 years for a particular person who comes in as a mechanical engineer, maybe, or someone who's interested in locomotives. Another example here, transportation. I won't go through all these, but same thing. You start off as a management trainee if you come to us. You go to a train master. That's somebody who kind of runs the area as far as the trains, all the way up through potential, service excellence or service design. You think to yourself, what does that mean? Well, it means a lot of things. It kind of advances how we do and build new facilities. It's really kind of cool. So again, that's 10 years of service. Let's look at a different one. Let's look at 11 years of service in finance. Where's that finance person again? Okay, ready for this? You come in as an intern, or whatever, management trainee, if you want to call it that. You become an analyst, then a senior analyst, an auditor if you want to become an auditing, program manager for audits. You go all the way up to a finance senior manager or higher after 11 years. It doesn't sound like, it sounds like a lot, a little bit. How long is 11? Does 11 sound long to you? Okay, some yes, I see some no's, some yeses. There's a no. Pretty good. Yes, it does sound a long time. So does that mean you're limited to doing 11 years? No. If you want to do it in 5, you could. It all depends on where you are. So one thing with the railroad though is if you come in, typically, you have a choice. You can go one way, stay there, or you can try a whole bunch of different things, which will require you to move. So if you go out there, my suggestion to you guys is be open. Like the gentleman right here in blue. When you go into a job and you don't really know what it is, are you kind of open to, what if they told you, hey, we want you to move to Houston? Where are you from?
I'm from Brazil.
Oh, fantastic. So you're gonna be in the States, I assume?
Of course.
Of course, yes, sir. Would you mind moving to Houston?
No, this is great.
How about Southern Cal?
That's also great. I want to get my surf on the list.
You got your surfing?
No, I'm not gonna surf on my own.
You want to? Okay, wow, that's impressive. You could pretty much go anywhere you want. That's kind of the cool part. You can tell your bosses and say, you know, you're smiling here, which is cool. I really want to stay in Houston. My family's from there. They'll say, okay, that's cool. But I also want to go to Minot, North Dakota, because I like the snow. Wow, okay, cool. So in that case, you can pretty much go wherever you want, depending on the job that you're in. And the jobs that we're in, if you look up here, we saw earlier, are pretty much everywhere, which is kind of cool. So you're going to actually, as a manager trainee, potentially, you could be moved almost anywhere you want, just to kind of get used to the U.S. How many people are from out of state, first of all? How many Texans first? How many out-of-staters? Okay, 2. Where are you from?
New York.
New York. Sir, behind you with the mayor.
California.
Where?
California.
Where in California?
Riverside County.
Oh yeah, no. So we have rail lines, and that map I showed you earlier, everywhere. So as long as you can work almost everywhere, you're in a great spot. If you want to go back to California, whatever that works. Sir, I can't help you. You can't go back necessarily to help BNSF out in the country, but you know, it is what it is for now. But I mean, it's still going to be something you hear about. So let's go on the last one. Technology services. We don't have any of you guys or any of those folks in the room. That's okay. But you think to yourself, what is technology services going to do with the railroad? And it's interesting. I never realized this until I get out there. Across from our facility, we actually have a headquarters, which is actually in North Fort Worth, around like when Loop 80 hits 35. So right past there to the west, we have 4,000 people who just do train stuff. And it's corporate. It's not like they're not out in the field or everything. They're in these really nice buildings with beautiful paintings and all that kind of stuff. It's a beautiful location. And we have probably 800 of those 4,000 are technology services, we call them, or information technology, IT. They are amazing. So what they do is everything with the train, if you think about it, and we'll kind of stepping ahead here, the locomotive is about a $2 or $3 million data system on wheels. You think to yourself, it's just a train. That's what I thought. I mean, these trains, the way they run, and they're so complicated, the systems that they have to keep them from, have the peak on time, all the tracking, all the efficiency, management, energy management, you name it, it's all in a system that would be amazed how much technology systems are required in them. So anyway, it's pretty cool. That's why they're $3 million. So anyway, and the folks who are interested, if you know folks in IT, say, hey, BNSF has a quarter of their people here in town do just this, and you can move all the way up to the top, do whatever you want to do within this is now 16 years. That's kind of good. But again, 800 people who just do that. So the other thing you haven't seen yet, I don't have a picture because I can't show it to you. We have what's called a network operations center. You're shaking your head. You heard about this? So it's like, think about the airlines have these big network operations centers where they run everything from one location. That is what happens south of here in Fort Worth, in North Fort Worth. This big room, it's probably half an acre, let's say, indoors, in a specially made building. That's like a F5 tornado, well, I don't want to say F5, let's say it's an F4 proof tornado building. That is where we house all of our dispatchers, all of our coordination from an operations perspective. It's pretty amazing. So we offer in the future, sir, if you ever want to bring students out, we'd love to tour them around. We do that all the time. Of interest, have folks come by, understand what we do, have people talk from the different areas. And we actually have the ability to go to the network operations. They're not in it, but you can actually watch it from the top and see everything happens below. It's pretty cool. So that's why we have hundreds of TS or IT folks. Kind of interesting. So let's talk about environmental. Who here is interested potentially in environmental stuff? Anybody kind of think about that? I want to go back to you, both of you. Actually, start with you, sir. Again, tell me, what are you interested in as far as environmental?
I like the ESG strategies that companies have.
Oh, of course. And explain what ESG stands for.
It's environmental, social, and governance.
Exactly. So a lot of folks are like, what does that mean? Well, it's a very good part of environmental, which has really grown in the past couple of years. We're talking about everything from the social side of environmental, the economic side, as well as the environmental side. But again, it's all the governance, exactly how that all interplays. Behind you, environmental, you have interest in environmental?
Yeah, I don't have anything fancy to say. I just think sustainability is important, and I like the idea of trying to marry, sustainability, ethicality, and practicality.
Yes.
Sort of like that.
And that's how we operate. We'll talk about this in a second, specific to sustainability, but The environment in itself, because we're in everyone's backyard, literally, we have to be very cautious about what we do, how we operate, where we operate, what we're using, what our vision is for the future, which I'll talk a little bit about here in a second. But that's one of the most impactful areas that we can help, not just for our generation, but for the generations yours, the future, and on and on. What we do now makes a difference down the road. Do you want a bear? No, you're not good? Okay. Did you want a bear?
I will take a beer.
Okay. You sure?
Yes, please.
Okay.
Thank you.
I saw you eyeing the bear. I'm like, I'll get two left, so you gotta be good questions. Let's keep on going the environmental side. So from our perspective, you've seen this before. There's actually an EPA calculator that kind of goes through this. If you have an idea of, how many houses am I going to be impacting and all that kind of stuff. But as far as our operations, because we reduce the carbon emissions, if you have a truck and you have a train, a truck, what does a truck get per mile of diesel? Not much. 15 miles per gallon, maybe. That's not much. We get almost 500 miles. We can move 1 ton, approximately 500 miles with 1 gallon of diesel. Why? Because we're pulling so much heavy stuff. Because we're extremely powerful locomotives. And that's the kind of thing, I will write all this stuff down. Actually, I see folks taking notes, and that's great. This is all online for you guys to know. This is actually a presentation. Pieces of it are actually on our website. If you look up sustainability BNSF, you'll go to our sustainability impact report. This kind of stuff is up there, and it's always updated with respect to what we're doing. But we're more efficient than trucks. 500 miles, for a pull a single ton of 500 miles versus a truck. Let's say 15 miles for how many tons, maybe a couple. So bottom line is, we're more efficient. That makes us it makes us burn and consume less carbon, excuse me. And that's kind of where we're going with this. Talked about here, I talked about this, 500 miles at just 1 gallon of diesel. Trains, therefore, are 3 to 4 times more fuel efficient than trucks. And there's less congestion, most of the time. So when you're traveling to California, you're driving out there, you might see this every time you drive to California, you're going to see a train on the side you guys. It's not on the highway, it's doing its thing. But then what if your trucks? Your trucks, they're in front of it, you can't get around them, it can be rather, you can tell, it's a lot of congestion. You get to California, trucking is just tough. So many, well, let's say it's a lot of congestion, let's put it that way. Whereas the train's still on the side, not in your way, all that kind of stuff. So that's kind of how we work. And again, it said here 25% of truck traffic moved at least 750 miles. Greenhouse gas emissions would fall by 13 million tons. Anybody doing calculations on that? I don't think so. If you did, then good for you. No, but it's pretty fascinating. These are things I never really realized that the railroad provided for not just the industry, but our community in general. So we'll talk about this. We already seen this a little bit. I won't go into too much detail. So bottom line is that last one. Our value for the environment specifically is with respect to reducing the transportation emissions. Much more efficient than trucks, and now we're looking at different types of energy sources, whether it's hydrogen, whether it's battery electric. So we're looking at how to make the locomotives more efficient by using other things other than fossil fuels necessarily. I'm talking a lot here. Any questions as we go along? I'm sure you got a few thoughts. Bear, questions? Okay. We don't want a bear, but still take a question.
Do y'all only use like diesel trains, or are there like other train types that you use, like hybrid or whatever?
Your question was, are we only using diesel trains? At this point, yes, but it's coming. We're testing battery electric. We're testing, we have a battery, you also have electric, but actually powers the locomotive. We're actually looking at fully electric, we're looking at hydrogen. We're looking at a lot of different opportunities to change that locomotive so it's not using fossil fuels. What we're also using is what's called biofuels. You may have heard of biofuels. So biofuels are more energy efficient because of the process that makes them. They're using different materials to make a biofuel versus just using the typical stuff to make oil or diesel. So that's a really good question. Did you have another one? Yeah?
No.
I thought you said you did too.
No, I didn't.
We're still waiting for you. So, we can talk about this. What's interesting is that when you think about one truck, it's going down the highway. So the gentleman back here is driving to California. He's gone home. Also, he's got 2 trucks ahead of him. Each truck has one container equivalent on top of it, each one. Train, how many have seen trains that have double stack of containers? Lots. It's pretty cool. So you could put roughly, I don't want to say a mile, you can put over a mile of containers in a row, double stacked, pulled by a couple locomotives. Much less congestion than if you got all those containers, put them on separate trucks and drove down the highway. Like, you'd never make it to California if you had that, 240 different trucks sitting in front of you. Well, that's what one train can handle. That's kind of this type of thing. It reduces congestion and of course lower emissions. If you had 240 trucks, the emissions versus one train, that's the whole difference between why we're so much efficient. So, talk about logistics parks. How many people have seen these huge distribution centers all over the place? Right. So, here's what happens. We get stuff on a train, it comes in from the West Coast, we bring it to one of those little places. And then they have trucks that come in and take it elsewhere. What we're trying to do is make these logistics parks where they're close, you don't really have to move stuff far. For example, train brings in a bunch of containers from overseas, puts it in one of our logistics parks. We're trying to get like Amazons and different companies to locate right around that location. So all they have to do is literally bring it across the street, they put it in their truck, here it's gone. A lot better than a truck coming from the West Coast, having to change its route, going all the way across the country to get where it needs to go to, wherever that is. Not great. This is much more efficient. So we're gonna keep on going. This is a good question that folks probably think about. So when you think about circular economy, does anyone know what a circular economy is, real quick? Okay, from a transportation perspective, or logistics perspective, it talks about what happens with different materials. Everyone has heard of recycling, right? Okay. So recycling can be good if you bring it back to where it started. You have a plastic bottle, gets used, gets recycled, gets made into a plastic bottle. That's the circular opportunity. So we're trying to make sure we do that more effectively. It's something that actually the trains can help with. A lot of materials can be used in other processes. Let's say ash. So you have a coal plant, it burns coal, makes ash, and ash goes to landfill. We can do better than that. We actually have to help in that process. We can take, for example, byproducts such as ash, move it on a train to a kiln that makes cement. It replaces the materials that go into cement, and you reuse the ash itself. It doesn't go to landfill, it becomes more cement. That's kind of the circular economy. So one thing we're working really, really heavily on is trying to make that happen across the board for all different products. So we'll call up, let's say this gentleman here, you own a paper mill, and you want to burn coal in one of your boilers. Well, option there is, what if you burn wood in your boiler, which you can do. So what we can do is we can try and say, hey, you know what? We'll figure out where the wood is. We'll bring it to you. We get it chipped, send it to your boiler. You don't have to use coal. So we're trying to figure out how to make these circular economy and benefits to help different materials, which people would call originally waste, and actually make them into a product, if you think about it. So there's lots of ways to do that, whether it's ash, whether it's aluminum, a lot of different things which we transport. So we're kind of that matchmaker of waste originally to product. So it's kind of something else we work on that you guys can get the trains. But if you do more than that, yeah, we do more than trains. So, talking about a few things, we talked about already some of the biodiesel, some of the opportunities. We're also trying to make sure that these renewable fuels are, well, you mentioned a situation ago, someone did actually here, the opportunity for different fuels, the biodiesel, you could have sustainable fuels of different types. We're trying to figure out how to do that, so we're kind of using that circular process to use fuels that aren't necessarily new fuels. Whether it's, again, biodiesel is a good example. I'll look at the slide over here. Same kind of thing with respect to biodiesel, renewable naphtha, sustainable aviation fuel. That's what the airlines are doing. So we're trying to do that too. We're thinking about all these opportunities and how we can become more efficient, and how we can actually make the processes smarter by not having to use new product every time. Yes, sir.
Do you guys work with another company, do that research, or do you guys have your own?
Yes, we have a lot of R&D. We do use a lot of consultants for this, because this is stuff, for the most part, our function is obviously running trains. We have the IT side, but we also have like our team. We do exactly that. We assess what would the carbon emissions be from Shanghai to Chicago, if you think about it. What happens if we're part of that loop, that lake? one thing we do look at, but to answer your question, yes. Good, okay, one more left. Did you have any other questions on that, by the way? Yes, sir.
I do have a question. When, at the beginning of the presentation, you said the heavier the better.
Yes.
Does that mean, the heavier it is, the more friction you have, and the more really brakes you're gonna be using instead of actually pressing the pedal, which is not a pedal to handle?
Well, it's interesting. That's a loaded question. It's a lot.
Yeah.
Let's unpack that. So the heavier the better. It's interesting. We carry, actually the locomotive itself is over 420,000 pounds. It's over 2,000 tons for one locomotive. It's got to pull all those different materials behind it. So what that means is once it gets going, it's hard to stop. So I could explain a little bit about how that happens. Air brakes and all the different cars are all connected. The air brakes stop and it stops the whole train at once. Not like one locomotive trying to stop the whole train or couldn't. But your question is, I think, what was your question specifically as far as the?
I guess with the weight,
Yes.
with the weight, it has more friction, so once you get it up there, it just stays at a constant rate, you just kinda have to press on the brakes, it goes into like the air brakes. Is that what you're talking about when you say it's better if it's heavier?
The better and heavier it is, but the thing is, we try to have less friction on the wheels, more friction on the locomotive, but all the other ones we want to be completely frictionless. That's kind of the cool part. Let's compare that to the road, or the road trucking. So, a road, actually a truck has wheels, rubber wheels. If you think of that, those rubber wheels are unwinding themselves on our highways. If you think about the friction, rubber's moving, it's literally unwinding itself, just like your car's doing your car tires do, they slowly get smaller and smaller and you have to replace your wheels. They're literally unwinding little by little on the highway. So our train wheels are extremely smooth, as are the rails themselves. So there's very little friction except for locomotive. So it pulls it, less friction, certainly less than a rubber tire on the highway, and that's kind of how it works. But once we get going, it can take a mile or miles to stop as far as the train is concerned. So yes, heavier the better, which is great. You can always pull it, but of course, gotta be careful how we operate. And that's the whole process of the TS. And the technology services look at all that, how it operates properly, et cetera, as far as the map itself. That's a good question. You've already got a bear. Good.
Do you want to hear?
Do you want a bear? Do you have a different question though?
That was my question.
Last bear, sorry guys. There's bear. So any questions so far? I'm getting towards the end here. I want to make sure I answer your questions we go through. Yes, sir.
I'm curious what renewable map that is, what does that stand for?
Anything that is recovered, if you have material that can be reused, it's renewable for the most part. So the question being, when it comes to renewable, we don't use naphtha in our processes, but that's one of the opportunities that we could certainly transport. So we do transport, again, the naphthas, any kind of renewable materials. You talk about sustainable aviation fuel or SAF. That's part of the process. So we're helping those different industries get these from different locations and move it to their uses in the airports in that case. Good question. Yes?
On the map you showed earlier about the routes, there were some dashed lines
Yes.
on some of the routes. I was wondering what those were.
It depends. For the most part, my understanding is that are more so either shared lines. For example, if you have a huge network of like spaghetti type roads or train tracks in this case, there are some locations where there's short lines, where they're actually trains that are, they're short lines or railroads that are owned by smaller entities. So a lot of those could be an area we don't own, but we use trackage rights to use their property for their traffic, is my understanding. So that's a good question. But it's interesting, when you look at the whole thing, if you were to put every single railroad together on one map with all the short lines, it would be intense everywhere. So our trackage rights change as we go to one city where we have to train, jump onto another railroad's track. They give us rights to do that, to pull their stuff at times across their property, and then we change back to ours or other railroads. So that's a good question. Questions?
Actually,
Yes, sir.
so let's say you were saying you were already doing research on full electric, hybrid, hydrogen trains. How long would it take to do an actual full change of all the current locomotives? Like 20 years, 30 years, 40?
It's a good question. Let's go back to the, actually I don't know the exact date, think about the coal and the steam locomotives. And and how they went over a time period to diesel locomotives, us moving towards the next level of efficient fuels, I'm gonna call it that way, or renewable fuels. It takes a while. Here's why. A couple reasons: technology, number one. Obviously, you have to make sure the technology works. Just like the Teslas, you know, or electric cars in general. How long was it before you saw those actually become pretty much everywhere? 15 years, 10 years. You know, so our process, we have a goal. You actually jump to the next slide. That's really good. I don't know how you did that. This is kind of where we're looking as far as our sustainability vision with respect to emissions. We call it 30 by 2030 or 30 by 30, if you want to call it that. So pretty much what we're going to do is we're trying to reduce 30% of our emissions by 2030 based upon a 2018 baseline. If they can way wide. So think about it this way. We're trying to reduce what we do with respect to opportunities of new locomotives, for example, opportunities for efficiency in running the railroad itself, making sure we're being efficient in how we actually run the railroad, and then biofuels. If you put all those together, you're going to get this reduction. And you can see this orange line. I don't have a thing on here. I don't think I'm trying to do. It's really light. So this orange line is actually the CO2 reductions. So if you think about it, we want to hit all the way down to here by 2030. And we're on our way. You know, kind of jumping around. We like to continue like this. We hope, and we want to be right back here by the end of it. So the opportunities for us is to do exactly what you're stating in these new technologies. There's other reasons why it's hard to do. Your comment earlier about the dotted line. If we come in with a locomotive and it's fueled by biofuels, or it's let's say it's an electric locomotive, which is not completely there yet. But when that electric locomotive shows up and it goes over to your short line, the dotted line, and we're like, uh-oh, we need energy, we need to plug ourselves in. If you're a short line, you might not have that. So that's the question is when you change the railroad, you've got to change the whole thing. Not just with the technology, but with respect to the logistics of fueling, of maintenance, things like that. I mean, for example, say the locomotive, he shows up and he goes to your location and he has a problem with his batteries, the batteries of the locomotive or something like that. You don't have the mechanics that know how to fix batteries necessarily. You have diesel mechanics. So you're gonna make sure that everything's all laid out operationally equivalent across the board. That takes time. So we're trying to figure out how to do that more efficiently. It's a good question. I don't know if there are reasons. Sorry. More questions on that? I want to go back real quick to the Teslas. It's kind of funny. Maybe 5, maybe 10 years ago, when you went outside, you went to drive around somewhere going to California. How many people saw Teslas 15 years ago? The guy's down here shaking his head. Not many, or whatever. It's 10 years ago. Not that many. So, what about now? When you go to California, do you ever see Tesla? Do you ever see electric vehicles out there? All over. Like, I don't know what the percentage is of those in the state of California. It's high. I'm guessing 15% maybe. It's a lot. They're everywhere. So the question being then is, will there be a day when you are driving back to California, sir, and you drive past a locomotive and it's going to be electric? That will happen, just like it did over time, just like it did for Teslas or electric vehicles. You'll be seeing that same kind of process for the locomotives in the future. Can't say when, or it could be hydrogen. It could be, usually what happens, they end up putting a mix of the electric versus the locomotive at both. So that will happen. But again, our objective is to have this, not necessarily electric vehicles, but to try and reduce our emissions by 30% by 2030. So kind of neat. It's a pretty challenging objective. Good question. More questions on that one? All right. So this is actually, I talked a little bit about, you jumped ahead on that with respect to locomotives. It's interesting because typically, if you look at a locomotive, that thing on the bottom is the fuel tank. It runs anywhere from, I don't actually know, but it's 3,000 or 4,000 gallons max underneath filled with diesel. So the question is, when you guys are making a electric vehicle or a zero emissions locomotive, where do you put the batteries? It's a whole different process. Each part of the locomotive is actually a part of a diesel engine of some type. It's fascinating, do we replace that and make it into a whole bunch of batteries, battery banks, and the like. So what you're seeing is, like I said, there's hybrids, where it's partial fuel, partial battery, but it's stuff that we're looking at, trying to figure out how to make a locomotive into a new locomotive. So then the other question, we talked about this a second ago, the technology. If we have 7,500 locomotives just for our company, roughly, how do we make 7,500 of those new locomotives? How long does that take? You got issues with respect to availability of minerals and materials to make the batteries or whatever. And that's kind of the other I guess you'd say delay, if you want to call that, making everything consistent across the board logistically. So, good question. I know you've got another question, I can see it.
Oh, it makes sense, like materials is also one that we need, like lithium for batteries, or we need more certain things to get to this level.
Yes, and that's it. The point he stated was, the materials to build these new locomotives or other takes time, and make sure we have all the right materials in the right locations. And again, make sure the technology works. So it's pretty fascinating. It's stuff we work with every day, every single day. Any more questions on that? All right. So these locomotives we talked about a second ago, I'm not really going into too much detail here, but with respect to BNSF versus other railroads, we're the cleanest, probably the most newest locomotive fleet in the industry. And that's pretty cool. We're owned differently than most companies. You ever hear of Berkshire Hathaway? We're actually owned by a Berkshire Hathaway. We're not a public company. Union Pacific, CSX, Norfolk Southern, Canadian Pacific, Canadian Northern, they're all owned by stockholders, stakeholders. You might have stock in some of them, your parents might. We don't have that. We're owned by this private entity, Berkshire Hathaway, which enables us to be a little bit different. You can kind of make more advances, I believe, than certainly if you have maybe a public owner, we call it that. So it's pretty cool. If you think about a locomotive though, I want to talk about one thing real quick. I don't think it's up there. Okay, so how old do you think locomotives are? When you see a locomotive out there, what's the oldest it could be? Any idea?
50 years.
How many?
20?
You said 20, I heard something up here too. 30, 20, 30, 50, okay. It's interesting is that every couple, say 5 or 7 years, we upgrade our locomotives. And we replace, 85% of the materials that say locomotive. And we make it kind of not new, but called remanufactured. If that happens every 7 years, you do this over and over and over again, you have a very, very, well, it's supposed to be an old locomotive, but still in great shape. It can be up to 30, 40 years old for one locomotive. Yes, sir?
Signal for 5 minutes.
Yes, thank you. I'll make sure there's no questions. But so the cool thing is that locomotives themselves are not just a amazing digital platform, but they're also an amazing maintenance platform. Yes, sir?
Do you guys make your own locomotives?
No, we don't. It's interesting. Typically, there's two primary ones. General Electric is now bought by Wabtec. Not far south of here, another great tour, big chance, sir, is to go to it was a GE plant, now it's Wabtec. That is a great tour. You get to see how locomotives are built. And if you need help getting in there, let us know. I'd be happy to figure out how to let you take a check at it.
We actually did a tour there last year. It's amazing.
It's amazing. And I hope at some point you'll be willing to come to visit us. We'd be happy to tour you around and show you what the operations looks like a little bit. But I'm going to kind of jump this real quick. We still have 5 minutes left. Intermodal, we talked a little bit about that. This is all of the material with respect to the battery electric dray trucks and battery electric hostlers that pull around these containers. We're trying to figure out how to make those all electric. We have some sites that are actually purely electric as far as intermodal yards for the hostlers and the things that pull big containers around, which is another huge savings, typically in California. We're going to jump really to almost the last slide. And you've seen this before. If you were to look at one thing, how do we do everything all at one time? This is kind of the summary of what we're doing. We talked about CO2. We talked about the customer's on-time performance versus necessarily getting there way too early. We talked a little bit about investing in the network infrastructure. We spend millions, hundreds, and actually almost billions of dollars on upgrading our infrastructure, which is pretty cool. And last but not least, with respect to our carbon emission target, which we covered about 2 or 3 slides earlier. So with that, we've had some good questions. I wish I had more bears. You guys have my name and number. I'd certainly like to connect with you guys if you were interested in seeing what we do. But I think it would be be a fascinating opportunity to kind of see what the railroad is about, because before I started there, I had no idea. And now I'm like, wow, this is pretty cool. So, whether it's jobs, if you're ever interested, go to BNSF Careers, check it out. And if it's ever something you want to learn about, I'm certainly available to discuss. So, thank you.